you can always ask me. That's we can try to keep it more informal. Many of the material, I guess, which I will be trying to cover, you must have heard some of these already, because since I saw that several topics were overlapping. And I have kept my chat box open here. So that's why sometimes you will see me looking at on this side because I have two windows going on. So you can put your questions on the chat. You can also unmute and ask questions depending on how you prefer. So let's try to get started. So we will with this. Yep, I think that's. So you can see my screen now?
Not yet. No, sir. No.
Not yet?
No, sir.
Yeah, now you can probably see it, isn't it?
Yes, sir. Yes, sir. Now it is visible.
Yeah. So let me minimize this. We're at the bottom. So we'll go to slideshow. Okay. Okay, so let's get started. You are having this course on composting technologies for municipal solid waste management. I think you had 7 class from Monday onwards. So today is the 4th day, and in the afternoon, so you had probably 6, 7 lectures already by different people. So many of the material here might be repetitive, but my main focus would be on compost quality. So if you if you have any question anytime, feel free to ask. Let's keep it more of an interactive mode rather than me just talking. And so there are some background material which, unless you tell me to explain more, I'll not do that. I'll just show you those slides and try to kind of go over a bit faster. Because I'm pretty sure that I was looking at the content of this program. So some of the basic information you already know. And I have already given these slides to Professor Chandrasekhar. So he has those slides, so he will share it with you as part of the course later on, or maybe he has already done it, I don't know. So let's get started. Since Professor Chandrasekhar is not here, he asked me to introduce myself. So I would, Professor Chandrasekhar is actually a very good friend of mine. He's senior, very much senior to me, but we know each other for almost 5 years now since I came back to India. And I have been to Warangal a few times. So those of you who are from Warangal, probably you may have seen me there as well. So I'm essentially a civil engineer. My bachelor's degree is in civil engineering from IIT Kharagpur itself, where I'm talking to you right now. And then I worked as a consulting engineer at EIL, Engineers India Limited, which is based out of New Delhi. But then I was out of 4 years, 2.5 years I was in Delhi. Then rest one year I was in Mumbai, working at offshore Bombay High project. Then I was in yeah. So I was also in like in Zamnagar for a little while. I was in Mangalore for a little while. So I have been at like I saw good bit of country while working for EIL. And then I went ahead and went to University of Florida, which is in Gainesville, Florida. It is the top university, one of the top university, I think within top 20 now. I think 12th or 13th ranked right now in US, and it's the #1 university, of course, in Florida. So there I did my master's to PhD, master's plus PhD together. So I don't have a formal master's degree. I converted from MS to PhD in between. So that's saved me some time because I was already a little bit older PhD student because I worked in industry for 4 years. Working in industry definitely helped me. Even it helps me today because it gives you a different perspective when you work in industry and you look at the problem, real problem on the ground. Then I worked in Florida for some time, 2.5 years. Then I was in New Zealand for some times. Then I was in US and Canada back for some time in US and Canada again. Then I came back to IIT Kharagpur, which happens to be my alma mater, as you know. And Kharagpur town is my like hometown. You can call it like we are not originally from Kharagpur, but I was born and raised here. So it's kind of hometown for me. So like I'm a local person. So that's why I know a little bit of Telugu too. Not that much. I probably some of the audience here might be Telugu speaking. I can just if you talk in Telugu, I can understand, but I can converse only a little bit. Kuncham kuncham. That's what we say, isn't it? So not too much. Um, then these are some of the profiles, which is these days like LinkedIn, Google Scholar, Twitter, Facebook, and all that, which is it's there. Okay, so we'll get started with waste, especially focused on compost quality. Again, I would say that any question you have, feel free to ask. Let's make it interactive rather than me giving lecture and you after having a very good, you all are at home. So after having nice rice and rasam and sambar and all those, you might be feeling sleepy. So better you ask some questions. I may also feel sleepy. That's why I have my like a green tea here. So to keep me awake. So you can, of course, you can keep your stuff too. So anyway, so in terms of, some of you might be familiar with this report. Anyone know what this report is? This is a cover page of a report. Especially if you're working on waste management, you may have seen it. Any idea which report cover page we are looking at? No one wants to take a chance? No, sir? Okay. So this is the World Bank
Bharat
report,
Mission.
which...
Hello, sir.
No, actually
It is about Swachh Bharat Mission.
Mission. You can, it's not the Swachh Bharat Mission report. It is actually the World Bank report. It's a global, as it says, a global
World Bank report. Yes.
It's the global snapshot. We do have a Swachh Bharat Mission report, which looks a little bit similar. Probably that's what you are referring to. The similar color combination is there. But this is a global snapshot, so it is a global report from World Bank. It came out towards the end of 2018, so slightly 2 years ago. This report came out on waste management global figures, where they talk about that the world generates approximately I can use my pointer here. So it's 2.01 billion tons of municipal solid waste annually. So that much waste is produced, and that's 2018 report. So probably it will have data from 2017 or 2016. So that much, and if you don't do anything about it, that is probably is going to go up, and that, let's put it on top here, and that's probably going to go up, and it will increase by 70% to 3.4 billion tons by 2050. So that's a lot of waste to manage. That's a huge amount of waste to manage. And for people like me, who I call myself a garbologist, I work with different types of garbage, municipal solid waste, industrial waste, e-waste, plastic waste, all different types of waste. That's what my research teaching is focused on. That's what my PhD was on. So if for someone like me, it's a lot of job opportunity here, isn't it? A lot of waste has to be managed, so probably lots of projects, a lot of consulting projects. So, but it's a huge concern. It's a huge concern that we are producing this much amount of waste, and most of it actually we are not recycling it properly. We are not doing the resource recovery properly. And composting is one of the method of doing that resource recovery. It's the organic waste treatment in an aerobic system. When we say composting, we are essentially talking about aerobic system. Anaerobic, we say anaerobic digestion. So if you look at the municipal solid waste, again, it is this picture is also from that same report. Here the source is given Water Waste 2.0. If you Google Water Waste 2.0, you will find that report. It's freely available. You can download it from there, and you will find these pictures over there as well. So if you look at the municipal solid waste, these are again global. These are the global numbers. Okay. So if you look at the global numbers, what is there in the garbage? What is there in the municipal solid waste? We have metal, we have glass, we have plastic, we have paper and cardboard, we have food waste and green waste, food and other green waste. Metal around 4%, glass around 5%, plastic 12%, paper and cardboard 17%, and food and green waste is 44%. Now these are global average data. If you look at the Indian numbers, you will see some differences. Of course, the Indian numbers, even within India, if you go by state, you will see some differences there too. City by city also, you may see a little bit of difference. Recently, we had, as part of the Smart City mission, I am involved in working with several proposed smart city in India, including one in Andhra Pradesh. Like we are working with AICTE. In fact, I have a PhD student who was earlier teaching at MVGR in Vijayanagaram. So he is working with me as a PhD student, full-time PhD student. He's almost finishing up. So as part of his PhD, he will probably do his synopsis later this month or early next month, and hopefully defends by the end of this semester. So his PhD is entirely focused on Vizag City. So integrated waste management for Vizag City. So he looked at a lot of issues around Vizag City, and then as PhD you have to do it. You cannot it's not a consulting work, but it's a PhD, lot of research. So he looked into the research part of how to better manage the waste, and probably you will hear from him at some point of time in future at some location. But his papers are coming out, so you can refer to his papers. So in Indian, again, this ratio will be slightly different. We will have more food waste. We have slightly less paper and cardboard. But the reason I was talking to you about that that different smart cities that we are working on, we found plastic to be in the same range. We found plastic to be around 10 to 17% in Indian waste too. And that's the data from Vizag, Guwahati, Kolkata, and then there was one more city. There is actually quite more city. We had a project along River Ganges with National Geographic Society. So National Geographic, that's the same TV channel, they had given us a project to look at the plastic waste along the River Ganges. So we did that waste characterization for Rishikesh, Haridwar. Then there is a place called Kannauj and Anupshahar along the River Ganges. We did it for Allahabad, Varanasi, and then there is a place called Sahibganj, Patna, and yeah, those, and I think Bhagalpur as well. So all these cities, we did this waste composition study, and we found the range to be in this particular range only, 10 to 13, 14, 15, 16%. Urban areas more, slightly rural areas. If you go to rural areas, of course, the number was much less. But mostly urban and semi-urban areas, the number varied from 10 to around 17%. So what is the problem? Say if you look at individually, metal 4%, glass 5%, plastic 12%, paper and cardboard 17%. So if we add them up, 5 plus 4, 9, 12 plus 9, 21, 21 plus 17. 21 plus 17 is what? 38%. So 38% of the waste should be easily recycled. We should not put these should not show up in the dump site, because each one of them has a market. Metal has a market, glass has a market, plastic has a market. Most of the plastic can be recycled, and some of the plastic which cannot be recycled can go for waste to energy. Paper and cardboard can be recycled. So this 38% of the waste, they should just get recycled. But still, why they show up in the dump site? Why are they not getting 38% recycling done? Similarly, food and green 44%. If you add them together, it's only 80%. So we are missing some of the other component here. So other components are not mentioned here. Okay, so don't worry about that. Those are the lot of textiles, leather, and those minor components which is there, maybe 2%, 3%, 4%. There is a long list. Altogether, that comes around 20%, which sometimes also have bricks, concretes, and other pieces too, depending on where you are. But food and green 44%. In Indian scenario, it is actually sometimes 50 to 60%. So this can also be composted. This can also be either composted or anaerobically digested. can produce fertilizer with compost, can produce biogas with anaerobic digestion. So 38 plus 44. So that we are looking at 82%. So 82% of the waste should not go to the landfill at all. But if you look at the dump site in your town, city, and all that, you see that most of the waste is ending up in the dump site. Why? What is the major problem? What is the major problem? Can anyone want to tell me, like, why it is that although there are metal
Hello,
recycling
sir.
happening,
Hello,
people
sir.
come to our house and collect metals.
Yes, sir.
Yeah,
Waste segregation is not. Hello. Yes, sir. Waste segregation
yeah.
is not done properly.
That's the number. That's what I wanted to hear actually. Because of the lack of waste segregation, especially short segregation of waste. Once the waste is mixed up, individually they have value. But when they get mixed up, you lose most of its value. You will, if you make compost, which has a lot of plastic pieces, a lot of metal pieces, glass pieces, who will buy that compost? Say if you and I are want to go and buy the compost, will we buy it? We will not buy that. If you see that if I take a compost in my hand and then I find all those metals and glass and other pieces, and if I ask for compost quality, look, show me the compost quality document, like your testing that was done, and if I find pieces of metals, glass, and other stuff in there, I'll not buy that compost, isn't it? Because I don't want to put that in my my kitchen garden or in my like flower and all those pots and other stuff. So lack of source segregation. Number one problem in India or country like India is lack of source segregation. So if we can do that, all these fancy technologies which comes on, like you hear about these fancy technologies, people inaugurating this, people inaugurating that, those are great. But unless you have source segregation, none of the technology is actually going to really work other than engineered landfill. You can put things in engineered landfill, which will degrade, which will take long period of time to degrade. You need a bigger space for engineered landfill. If it cannot do source segregation, that's the only option. To do anything effectively, for effective waste management practices, source segregation is the key, and that's needed. And at the bottom of this, if you look at this on this side, these are the different countries, different areas, regions which are producing different amount of waste. So we are in South Asia, which is at number 3. So East Asia and the Pacific is leading in terms of waste production. Then we have Europe and Central Asia. Then we have South Asia. Then comes North America. So South Asia is producing more waste today. East Asia and the Pacific includes China. South Asia is producing, which is India and countries around India. We are producing more waste than North America. But if you divide it by population, the per capita waste is very less. Per capita waste production in Indian scenario is very, very less as compared to the North American scenario. But if you look at the total waste generation is much higher. So there is again, looking at the jobs, there will be a lot of waste related jobs that can happen again if we do the source segregation. So if you don't do source segregation, then it's very difficult. If there are highly populated country, if you look at the populated country in terms of, say, for example, look at Singapore. You can divide India into, say, 400 Singapores. So it's that not the, see, population it's the discipline what is needed. It's the discipline having the infrastructure. You go to Singapore, if you have visited there, you will find they have wonderful source segregation system in place. So it's population is actually, unfortunately, we use that excuse many times. Our politicians uses this excuse, our administrators uses that excuse. Oh, we have too much population, that's a problem. We have too much population. Look at the population. Like, what is the problem? Problem could be population density. Like we have too many people at one place. That could be the problem. But population density of Seoul, Korea, is also very high. Population density of Tokyo is very high. Population density of Singapore is very high. And there they can implement it. So what is needed is actually having a proper system in place. Unfortunately, in our country, and many of the countries like Asian or developing countries, we never put system in place. What we put, like, we are so much into personality driven. I will not go into specifics. I think this is being recorded as well. So I will not take any name. I don't want to get into any controversy, but you understand what I'm trying to talk about. So we are so much a personality driven society, whether it's a chief minister of a particular state or a prime minister of the country, or so we never we never actually developed our system. And whatever system was developed in first few decades after independence, that also got destroyed in last few decades. So that's what we need. We need a system here where doesn't matter who is the mayor, doesn't matter who is the chief minister, doesn't matter who is the governor of that state. Certain things will definitely happen in the same way. We will have the waste management happening in the same way. Not that one mayor comes, he says waste to energy, other mayor comes, he says uh, like composting, or the third person comes, says something else. So what is needed actually is developing that system. And that system development requires, of course, it requires political will, but at the same time, it also requires like trained manpower. But like I have done a lot of DPR review for state of Bengal and state of Bihar over the last 5 years as part of the Swachh Bharat mission. Almost, I think we had reviewed close to 80 DPRs. We were a part of a team, so two of us were there. So around 80 DPRs we have reviewed over last 5-6 years, and we have visited the sites as well. We visited the cities, and then when I was working in Guwahati, when I visited the people involved in waste management, they also do not understand waste management. People who are working on the field, they don't understand why this is source segregation is important. Many times the workers, I'm talking about the workers, because see, we are talking right now I'm talking in English, but if I have to talk to the local workers in Andhra, I have to put it in Telugu in a very simple language. And that kind of capacity building, the training program is not happening. And when you have things thrown from the top, oh, we have to do it, but there is no buy-in from the bottom, then things don't work. Say if you want to push for a waste to energy plant, local engineers who have little knowledge about the waste management because they were never actually taught waste management course, they're like civil engineers of even from IIT can get a degree without having waste management. Just a little, they may have a 1 week or 2 week of 1.5 week of waste management as part of their environmental engineering course. So how you expect them to be like understand all the nitty-gritty details unless they get trained? So there has to be a lot of training, capacity building, and other things has to happen so that so that one capacity is the like a human capital capacity. Other is the investment in infrastructure. You need to have infrastructure in place. For going the set segregation, nobody actually wants to harm the environment. If you make it convenient for them, if you make it hard for them, then source segregation will not happen. If you make it convenient, you have like for example, in our campus, that too after it took a lot of effort. I came back in 2015 after trying so much. In 2017, we started looking at after making so much of effort that we should have source segregation in IIT Kharagpur campus. Then finally it happened almost 6 months ago, where now it has covered the entire campus. So that's but that too in a educated campus like here. So think what will happen if it in outside places. Some cities are doing decent job. Some I find Vizag city to be a bit progressive. Certain pockets of Vizag is doing pretty good. I've visited them many times. But there are some cities where they don't do anything. So again, since it is personality driven, if the municipal commissioner is interested, if he likes your idea, it will be implemented. If he doesn't like your idea, it will not be implemented. So that should not be the case. It should be a system driven, that waste management will happen this way. It doesn't matter whether it is A, B, or C on the chair. So that is what we need to do. That's what it is there. say if you go to Singapore, if you go to Seoul, if you go to any places, they don't change their policy overnight. And first of all, when they make the policy, they do a lot of deliberations, lot of discussion goes on. You have to bring all the stakeholders on the table. So tomorrow, if I tell that compost should have this quality, but I don't give them source segregated waste. As a city, I'm not giving them source segregated waste, but I'm telling the compost company that you have to maintain this quality. How he will do that? That's totally ridiculous. Like how a company can do that if the raw material coming to him is totally bad, how he can produce a good quality product? He will not be able to produce a good quality product. To expect him to do the good quality product means that person does not understand waste management. So if you look, again looking at that, so here some more components are given to you. So food and green 44%. That's what mostly what you can go for composting. Again, this is the global figure. The Indian figure is slightly different. Now, in terms of what is happening with this waste, open dump this is again global. 33%, 1/3 of the global waste is just going in open dump. 1/3 of the global waste is just going to the open dump. That's not even a sanitary landfill. I'm assuming that all of you are civil engineer or have some environmental background. So I'm not talking in what is a sanitary landfill or what is it. So I assuming that you know what is a sanitary landfill and all that. If you don't, you can always ask me. So this is it's 33% just going to open dump. Then there are some 25% which says landfill unspecified. So they don't really know what kind of landfill is that, whether it's a sanitary landfill or whether it's a it's your open dump. So that's another 25%. So if you add them up, 33 plus 25, so that's 58% of the waste is totally mismanaged, we can say. Totally mismanaged, 58% of the waste. Rest, we have some composting, 5.5% is compost, 13.5% is recycled, 11% is incinerated in a waste to energy plant. Then we have some controlled landfill, we have sanitary landfill with landfill gas collection and all that. So if you look at the income level, low income countries, 93% open dump. Low and middle income countries, 66%, 30% in upper middle income. Even in high income countries, 2% is open dump sites. So it's not that high income countries don't have any dump sites. In the remote areas in high income countries, you will find dump sites. In Appalachian Mountains in US, in the Tennessee, Virginia, North Carolina, that area, Appalachia Mountain, you will find some open dump sites. Then landfill is the sanitary landfill. Is as you go from high income to low income, you can see that high income is actually landfilling is less, but they do a lot of recycling, 29% recycling, 22% incineration, which is with incineration is your thermal treatment, not open burning. Open burning of waste is totally no. You should not do that. And so as you go to the lower income countries, you see only 3% is the sanitary landfill, 3.7% recycling. Now, if you look at the Indian data, we say we recycle. I think sometimes we say almost our recycling rate is pretty high if you look at the CPCB document. But those are informal recyclers, and they do a very good job. No, nothing wrong with that. They do a wonderful job in terms of recycling. But the proper data collection is not there. So we don't really know the proper data collection happening. And sometimes they also need skill building. So they are, especially with newer kind of material which is coming in, that mixed plastic with plastic wrapped all around the bottles and other stuff, they need to have a better recycling system in place. A more mechanized system is required to do some of those jobs. So since the informal recycling is not captured here, that's why you see the numbers to be much lower. I think we will probably be now in lower middle income. So it's around 6%. But if you look at India, it's actually much higher. But again, we know that we have a lot of dump sites in India. So here, if we just jump to this, you can look at the individual numbers later on as well. You have these slides. You will, if you don't have, you will have these slides. South Asia, where we are, 75% is open dumping. So 4% in landfill, engineered landfill, 16% composted, then 5% recycling, and then hardly any anaerobic digestion or incineration and all that. Anaerobic digestion we see more in Europe. You will find in Europe anaerobic digestion is there quite a bit. So that's where like a anaerobic treatment to get biogas. So these are again mixed, as you can see, different parts of the world, different, and based on the situation, things are different. So if you look at the India as a country, then again another issue we have is we try to have one rule for the entire country on I can understand that for hazardous waste, but for municipal solid waste, what needs to happen with municipal solid waste, it's very site specific. Say if you have market for compost, it makes sense to make a compost. If there is no market for compost in your area, and if you have to say if you are in Hyderabad and nearby not much I'm not sure whether nearby a lot of agriculture activity happens. I'm just giving you a hypothetical scenario. If we are in a city and where up to maybe 100 kilometers or 150 kilometers, not much industrial activity, not much agricultural activity, not much fertile land. So even if you make compost, what you will do with that compost? If you cannot sell those compost, what is the point of making that compost? So economics has to play a major role. Like economics does play a major role. That's why many of those compost facility, even if they made good composting, even if they make good compost, they are not able to sell it. And if you have to take that compost and bring it to 200, 250, 300 kilometers to the market, the amount of gas, amount of petrol and diesel that you will use to travel that compost, actually you may end up doing much harm to the environment than good to the environment by making the compost. So because of all the fossil fuel emissions, and that kind of analysis we do using concept of life cycle assessment, which I teach an online course on life cycle assessment. Some of you might be familiar with I have several online courses. If you go on YouTube or Google, if you put I think my name, waste management, you will find several courses. There are courses on plastic waste, there is a course on e-waste, there is a course on integrated waste management for smart city, there is a course on basic environmental science and engineering. There also a course on what was my last course? I think those are the courses. There is a course on life cycle assessment. So total 5 courses are out there. So if you want your students, your PhD master's students to take advantage of that, you can always it's free. It's on YouTube. Anybody can listen to that. And if you have any query anytime, feel free to contact me. I will be very happy. That's the reason. I came back to India almost 6 years ago now, 5.5 years ago, to raise awareness on waste management. And that's why I developed and built all those online courses, so that more and more people can take it. And including all those 5 courses over last 4 some years, more than 100,000 students have taken those courses. So it's actually maybe 110, 120,000 students if I add them up. So there are so it's working. So at least and it's being rerun. So hopefully if it's being rerun by IIT Madras, so that means it is of some quality, isn't it? Otherwise they will not rerun this course. So thoda to quality
Yes, sir.
Anyway.
Hello, sir. Just now I have completed your
Yes.
integrated waste management for smart cities. It was a fantastic course, sir.
Okay. So you saw all this slide.
I got 79%. Yes, sir.
How much did you
yes,
get?
Sir.
If I ask.
I got, sir, 79%, silver medal.
Okay. So I added this video, this slides in this year's offering. So you may have seen already this. What I'm talking is you must have listened to it already.
Yes, sir. Yes, sir. But it is very interesting, sir. So I am listening now only.
Okay. Thank you. So, and then if you look at by the income, because see income. So what I was trying to say that in country like India, which is so big, What will work in the example that I was telling you, that if you have a in an urban area and if you want to set up a compost plant, but you are not able to sell the compost in nearby places, then it becomes a problem. It becomes a problem for you to for it the plant will not be sustainable for a long period of time. So to overcome that, you can go for an anaerobic digestion where we can produce some biogas and use that biogas. So that's what we have proposed to Guwahati. I don't know whether they will listen to us because they have taken up the report, but hopefully they will listen to us. Let's see, because there is a lot of pressure on Guwahati city to set up a waste to energy plant, like an incineration plant. And based on our work, which was quite extensive, we had sampled Guwahati city for 3 different seasons over like 1.5 year. So we have sampled from each and every zone. So there are 6 zones. So we have sampled in 6 different zones and multiple samples. So we try to get a very, as much as possible, a representative sample from that city. Spending a lot of time and energy over there. And then our data suggests that waste to energy incineration plant as of present situation in Guwahati is actually not a good idea because they don't have that much of a calorific value. And they don't even have that much of combustible waste. So because for any plant you need there is something called economy of scale. You need to have certain amount of waste coming in. For a waste to energy plant, you need at least 250 to 300 tons per day. And that much waste they don't have. So, and if they have to truck in waste from nearby places, there is a transportation cost. So, and the color, because it gets so much of rain, Guwahati, it's a rain is there, so and their collection system is not covered. So there will be moisture intrusion into the waste. So again, the calorific value will go down because of the latent heat of vaporization. So all those factors tells us that they should not go for waste to energy plant right now. Maybe in future, once the city develops a little bit more, they have more waste to work with. But since they have too much pressure on to set up a waste to energy plant, they may go ahead and do it, which will be against our report. But our report will be kept in a locker in an Almira, and maybe 10 years down the line, somebody will open it. If that happens, that's really sad. I got my money, but that's not what that's not I wanted. Like if I had to make money, I could have just stayed in US. I could not have. I don't need to come back to India. So, but that's not I want. I want that scientifically, what is truly can be done. Let's do that so that we can. So let's do a scientific solution to waste management, not some other. But unfortunately, things are very complex. It does not happen that way. We all know that, but we should keep on trying. We should not keep on trying. At some day it will happen. So it's not today. It will happen tomorrow. Okay. So coming back to here, if you look at global waste composition by the income level, so we will be somewhere here in the lower middle income. So around 53% is the food and green. So there is a lot of potential to produce compost in India if we keep this food and green separate. If it gets mixed up with plastics and metals and glass, then the compost will not be of good quality. And if you look at globally, again, a lot of food is wasted. And unfortunately, that tendency is coming to India too. There was a study done in US a few years back where they found that a typical, sorry, it was done in Canada, I think. So, any question? If you don't have any question, please mute so that we don't hear that background noise. So, okay, so what I was trying to say is that there was a study done where it was found that a typical North American family, they waste close to $100,000, sorry, $1,000 worth of food waste in a year. $1,000 worth of food is wasted in a year in a family of 4 in North America. So that's, say if a family of 4, $1,000, Christmas just went by. So $1,000 divided by 4 is $250. $250 will buy them a very good iPad today. So they could have bought good iPad for all 4 of them and not if they not wasted this food. And since they, and it is not again. It's L. All organisms. Preeti, can you please mute? Or if we have somebody from NIT Warangal, if you can mute him or her actually, that would be good.
அருணா மேம் நானோ எலக்ட்ரானிக்ஸ்ல உங்களுக்கு வருமா சர்க்யூட்ஸ் அண்ட் சிஸ்டம்
சர்க்யூட்ஸ் அண்ட் சிஸ்டம்
இது நீங்க தனியா எடுத்துக்கணும்
I'm not able to mute her. So please mute so that we don't get that background noise. It's irritating, isn't it? If you have some question, please ask. Otherwise, please mute. So what I was trying to say is that that you have that like $1,000. That's a good amount of money. And unfortunately, that kind of thing is coming to our Indian homes too. It has become a fashion to waste food. If somebody calls you at your apartment for dinner, and if you eat the whole thing, that means people sometimes feel like that. Pata nahi ye bhukkad aadmi hoga. Like it said, he was so hungry, he ate everything. But take only that goes as much as you can eat. So don't waste too much of food. But in the Indian scenario, these are some numbers from US. These are in pounds. Those pounds are say pounds is around 2.2 pounds is a kg. So you can convert that into the kilo. So so that's not important that much. What I'm trying to say is that when you waste food, it's not only you are wasting food. There are a lot of water goes into making those food as well. So you're wasting water too. In Indian scenario, what is happening is nearly 1/3 of the food which is our fruits and vegetables, which is generated on agricultural farms. It gets wasted even before it comes to our to our home. So in the food transportation, from the agricultural field, from the farmer's place to the market, like mandis and big wholesale market, to the market like local market, nearly 1/3 of the food is wasted. And we all know, like, our farmers don't make that much of a money. So most of our farmers don't make that of a money. So if we can help reduce that food wastage, it would be a big achievement for a country like India. So we have to reduce. If you don't do food waste, if you benefits of keeping food waste out of landfill, out of waste, it's that you can reduce greenhouse gas, because you will all those methane, CO2, those. Also, you can have green jobs in terms of composting plants, anaerobic digestion. Compost can restore the soil. Those of you who are from agricultural background, you know that our soil quality is deteriorating because of all these fertilizers and pesticides and other things that we are using. So our soil quality is deteriorating. So we have to restore soil. We have to use organic fertilizer. Reduce need for landfill also. So that's kind of gives you some idea about like why like we need to have we should avoid trying to have this food waste, which is a good source for composting, but we don't want food to be wasted. So, and in case it is wasted, in case it comes in a waste stream, for doing, and like if you want to do any effective waste management, we talked about that earlier, you have to have segregation. This piece I wrote in 2018, in January 13, 2018. I wrote this piece in Economic Times. You can find there if you are interested. There I talk in a little bit more detail. There was some more article done by. There is one. I'm forgetting the first name of the journalist. His last name is Sarma, from Assam. He did this. He did a big study on big articles, basically one page on waste management on that particular day. It's almost 3 years ago now, and then he asked me to write a piece, and he quoted me on other articles as well. So it's So here we talk a bit in detail why segregation is important, whether you talk about composting, whether you talk about anaerobic digestion, whether you talk about waste to energy plant, whether you talk about like any other treatment system. Without segregation, you cannot really do much. So now coming to like organic waste, it can be composted to produce fertilizer. You can do anaerobic digestion to make biogas to electricity. Residue from this anaerobic digestion can be composted, can be fertilized, and can go to rural areas. There is a concept these days of even producing biochar. Some of you may have seen, my lab was covered in quite detail in many newspapers in the country last year in early 2019. No, sorry, in early 2020, where we have produced from food waste and leaves and other stuff. We call it a yard waste. From food waste and yard waste, we produced some hydrochar, and which is using that hydrothermal carbonization, and that hydrochar can be used as a partial replacement for coal. So its calorific value was closer to lignite, and then you can also use an adsorbent material. You can use it as a and the further research actually done by one of the students from NIT Warangal only. He did his master's. There is one Professor Reddy in NIT Warangal environmental engineering. So he is a student. He did 1 year MTech project with me here at IIT Kharagpur. So he produced, taking that further, he produced, took that hydrochar and produced a carbon material which can be used as an energy storage material. So think about your food waste. First of all, you should not produce any food waste. But in case you produce a food waste, it could be agricultural waste as well, agricultural processing waste. Say when you make potato chips from potato, there is a lot of food waste there also, agricultural processing, food processing waste. So we can take those waste and then we can make a material which could be part of your cell phone. Isn't it cool? It can be the batteries of your cell phone can be made from that waste. So that's what our lab study suggests, that we have to do a pilot. We are looking for some pilot partners. Some companies have approached us as well, where we are trying to do some pilot on that. So in terms of biochemical process, again, you may have heard from many other professors in last 4.5 days on different biochemical process. Aerobic composting is what we are focusing here. And then there are low solids anaerobic digestion, high solids anaerobic digestion, aerobic composting. Those of you who are interested more in detail, you can always go on YouTube and look at that biological treatment chapter from the course that just now one of the participant was talking about. So major objective here is to convert the organic matter in waste into a stable end product. Aerobically, we call it a composting process. Anaerobically, we call it like a fermentation, anaerobic fermentation process or anaerobic digestion process. But for composting, it's a succession of facultative and obligate aerobic microorganisms. They feed on the organic matter and they convert to new cell tissues, and that's how the compost is done. Composting is an aerobic biological process which like natural occurring microorganisms convert the biodegradable material into humus-like compost. It's basically biological reclamation of organic material, a natural decomposition process. You can decay of fallen leaves, decay of wood, animal carcasses decaying in a preserve. So all those are kind of type of compost. So what happens in a compost? This is a typical waste composition. If you look at from a biological perspective, biological treatment perspective, so you will have some moisture, you will have some inorganic material, then you have these two together, like the light blue and the green together, that's the volatile solid. So among those two volatile solid, that light blue one is what is known as the biological volatile solid, which is an organic fraction of biodegradable component, which gets destroyed during treatment. Destroyed means it gets converted into different forms during treatment. Then we have some residual volatile solid, which is organic fraction is there, but it does not degrade under biological conditions, under composting conditions like plastic or some other material which is very high in lignin. They don't degrade very quickly. So those could be part of there as well. So when you design a compost plant, you are looking at this pie chart. So it's a biological volatile solid. This is the pie chart that you need to focus on when you are looking at a compost plant. So compost can be made from grass clippings, from your kitchen scrap, could be garden trimmings, food scrap, could be leaves. All these things can be used up to make compost. It's a natural process of decay of organic into valuable humus material, which is called a compost. Now, composting, it's you supply organic material, you supply some minerals, because see, it's any biological treatment. It's the microbes. It's the microbes here. It's aerobic microbes, and then in anaerobic digestion, it is the anaerobic microbes. So it is the microbes which is doing the job for us. What we are doing as a compost engineer or a solid waste engineer or environmental engineer is we are creating the condition which is suitable for these microbes to work. It is the microbes which does the work for us, and we have to make the condition suitable. So microbes need oxygen because it's an aerobic system. So you have the oxygen supply. So you need oxygen. Oxygen has to be distributed nicely through this compost pile. And you need to give them some minerals and some water and some minerals and waters as well. So minerals, because see, when we eat, we do not only eat rice and dal, we need to take fruits, vegetables, and other stuff to supplement our minerals requirement and all that. So this bacteria, the microbes also needs to have some strength, and so they can produce and their population can go up, and they can do the degradation of the waste. So for that, you need to provide certain nutrient in there. So we have to have proper carbon nitrogen ratio. So, and then of course moisture is needed for any microbial process. Moisture is needed. So that's why when you may have seen certain bottles, on the top of the bottle it says store in cool, dry place. Now dry means if the moisture is not there, microbial action will not be there. So whatever you are keeping will not get microbial action, will not get bad very soon. Dry, the cool means at the lower temperature, again the microbial activity goes down. That's why we use refrigerator, isn't it? We use refrigerator so that in refrigerator things can last for a longer period of time. It will not go bad. If you keep it outside, it goes bad because the temperature is more. In refrigerator, we keep it below 4 degrees centigrade. So to keep it safer. So, and then it produces organic matter, which is your compost, and some minerals are also there that your fertilizer has to have certain NPK value, so that you need to maintain that. It will be some moisture. Then you also have some microbes present, your earthworms and other things present in a matured compost. And in the process, we do lose some moisture, we do lose heat. It's an isothermic process, so heat is released and carbon dioxide also goes up. So carbon dioxide also gets released. It's an oxidation process, so carbon is getting converted to CO2 as well. So in composting, you need to have a better feedstock, which is good carbon nitrogen balance. So that's why nutrient balance. You have to have a good particle size for the good moisture, good air movement, moisture content, oxygen flow, temperature. I'm pretty sure you talked about this earlier with different lectures you had in last 3 days, isn't it? So these are the typical carbon nitrogen ratios. So we can go over that a bit faster. I think I have another half an hour. So I'll go a little bit this faster, and then we can keep some time at the end for question and answer also. So it's your different kind of feed. So that's your carbon nitrogen ratio. And we need to have an optimum carbon nitrogen ratio of around 25 to 30. So we have to mix the material, some material which is high in carbon and low in nitrogen with the other way to get the optimum ratio of around 25-30. So here these are, if you look at carbon and nitrogen, these are some material which is high in carbon, like your hay, cardboard, leaves, sawdust, chipped wood, newspaper, egg cartons, wrapping paper, paper towels, straw, toilet paper rolls, dried grass, shredded paper, 100% cotton fabric if you have a small pieces of that. So they are all high in carbon. Then we have this vegetable trimming, algae, green leaves, grass clippings, seaweed, tea bags, then coffee grounds, house plants, weeds without seed heads, old flower bouquet, human animal hair, aquarium water for fresh water only. If you're using those, they are high in nitrogen. So you can take a proper ratio, you can mix them properly so that you can have a proper like carbon nitrogen ratio. So when you go for what you can compost dry leaves, wood chips, shredded paper, sawdust, kitchen and food roll, your straw and hay, you can do that. Cardboard, then your egg cells, feathers, tea bags, coffee ground, fruits and vegetables waste, all those things can go into your composter, and you can make compost from that. We already talked about carbon nitrogen ratio between 25 to 35. So that's the carbon is to 1 nitrogen. Particle size around 50 mm. Moisture content 50 to 60%. There's the airflow given. Temperature 55 to 60 degrees centigrade for first 3 days. Then you periodic turning at 15 days interval. These are again depends on different types of composter. And I'm assuming that some of that has already been exposed to you in last 2.5 days. You have how much heap size you can have, what kind of activator, microbial organisms, and all those things you require. So in terms of optimal composting, you need oxygen concentration of in the range of 13 to 18%, and the particle size is between 3 to 50 mm. Your carbon nitrogen ratio in certain based on your active composting, curing, and product. Moisture content, temperature, pH, all those you can look at. There is a CPHO manual which you might be familiar with. CPHO manual is there. Also, Swachh Bharat document, Swachh Bharat, the big compendium of Swachh Bharat is also there, which talks about these conditions there too. So you will find similar numbers in terms of temperature and moisture content and all that. So what is happening here is your microorganisms, they react with organic matter. They basically use the organic matter as a food source, and they produce CO2, heat, and finally the compost product. So three phases of under optimal conditions. So you have a mesophilic phase. It lasts a couple of days around at 40 degrees centigrade. Then you have thermophilic, and then you are also having. Let me switch off my video. It was telling me that there was some problem with that. So okay. So then you had thermophilic, which can last for a few days to several weeks. Then you can have several months of cooling and maturation phase as well, which can give you more like acquiring more a better matured compost, which you can get. Aerobic bacteria, which the aerobic system we're talking about. So there are a diverse set of aerobic bacteria. We have fungi, bacteria, insects, and worms. So those kind of works on they works on our composting process. Anaerobic, again, I'm not going to in detail on that. So this is what reaction which takes place. So you have this matter, your compost, we call it feedstock. With in presence of oxygen, in presence of nutrients, you say microorganisms will act on it, produce compost, produce new microorganisms, and the old one will die and they will become part of the compost. Then sulfate, and then some heat is also released because of exothermic process. So end product remaining after microbial activity is called compost. The new cells, like new microorganisms that produce, become part of active biomass, and when they die, they become part of compost. So that's what they're also organic matter. This is a typical compost plant design. If you are using a municipal solid waste, co-mingled municipal solid waste, if everything is coming together, say in a country like India, where still a lot of things are coming together, so this collection vehicle can bring it. Then you can have a front-end loader, where you can do some manual separation of any bulky items there. Then you can do with a conveyor belt, you can have a manual separation of recyclables. You can take the paper out, glass out, metal cans out. Then the primary shredding, size reduction, do the magnetic separation to get the ferrous metal out. Then you do oversized material, like you do another screening. Then it goes to a mixer where you put some water, nutrient, other additives as needed. If needed, you have to put them in there. Then it goes to plug flow compost reactor. It stays there for like a couple of weeks, depending on the type of reactor you have. Then your maturation phase. Again, you will have the screen. If needed, you will shred it further. And then you will, whatever is the smaller size will go for bagging. Bigger size again will come back and get shredded further. And then it can be bagged as a compost through the bag house. So this is talking about a mixed MSW. But if you, that's not preferable. it talks about if you have a mixed MSW, this is what you can go for. But you are putting a lot of effort in segregation of the waste at the centralized location. So, and because of mixed MSW, there is always a chance of reduction in the quality because your quality may go bad. So one of the critical thing is having good carbon nitrogen ratio. And so many times you have to blend the organic waste together to get a good carbon nitrogen ratio. Here, for example, digested sludge has a ratio of 15:1. Your leaves and other things has a ratio of 40:1 to 80:1. So if we can mix this together, we can achieve around 25:1. We have to cut it in a particular ratio. Newspaper has very high, so high in carbon, low in nitrogen. Yard waste is high in nitrogen. You saw other example which is high in nitrogen as well. So these are some tables of different stuff. This is again, you can find it in any textbook. These numbers are available and you have these slides, so you can look at those later as well. Temperature, there is a temperature rise, and we also want to ensure that like there should not be too much temperature rise. If it goes above 66 degrees centigrade, biological activity is reduced significantly. So we don't want temperature to go up too much. So if the temperature rise is happening, then we monitor the temperature, we add some air, a cool air. So when the cool air goes through, the temperature goes down. But we do want temperature to be around 65, above 60 to between 60 to 66 to kill most of the pathogenic bacteria. Most of the pathogenic organism, they need to be, they can be killed by those in that particular temperature range. So that's also important for us to look at. Then pH control is needed. pH because as we know, the microbes work in the neutral pH range. Most of them like to have in neutral pH range. So pH 7 to 7.5 is the mesophilic stage during initial. You will see that. But since whenever there is a microbial degradation, there will be some, although you want to keep it aerobic, there will be some anaerobic pockets. And then if you have anaerobic pockets, thing will degrade anaerobically and it will produce acids. And remember that anaerobic 4 steps like hydrolysis, acidogenesis, acetogenesis, and then methanogenesis. So in that acidogenesis, you will have produced some acid and the pH will drop. So, but we need to make sure the pH does not drop too much. Otherwise, if composting will struggle. So we need to keep the pH in the neutral range, slightly acidic to neutral range, not too much, not below 4.5. And in terms of high pH, we also don't want to have too much high pH, because if you have too much high pH, that also becomes a problem, because what will happen is ammonia, nitrogen, which is an ammonium form, that will get converted to ammonia. And remember that NPK, you have to have certain nitrogen there for. So if N is lost as ammonia gas, so your compost quality goes down. So you need to make sure that temperature, the pH should not go above 8.5 as well. So that's important. So this is a typical how the temperature changes as a function of time in a compost, and this tells you the range of temperature, and also it shows you the range of pH. So pH kind of drops a little bit, then finally it goes to slightly basic. So other environmental factors, we have to keep the moisture, typically 50 to 60% on a wet basis. How moisture? So we don't want, again, you need moisture, but you don't need too much moisture. If you have too much moisture, what will be the problem? Your void spaces will be filled with water. If the void spaces get filled with water, air will not pass through, isn't it? We have to do aeration. It's an aerobic process, so we have to do aeration. If the void spaces is filled with moisture, your aeration will not happen. So it will be difficult to push the air through. So that's the reason we have to keep a very close eye on the moisture content as well. And sludge is a good source of moisture. If we have to add moisture, sludge is a good source. Organism and blending and seeding, you need to have organism necessary for decomposition. So we do mix 5% of partially decomposed compounds back to speed of the process. And again, sludge is also a good source for giving the seed, giving the microbial population. Particle size 25 to 75 mm is beneficial. Expose more surface area, allows for easy air movement. So you want to make sure that there are good void spaces. You have to do mixing and turning to make sure there is to prevent the drying, caking, or air channeling. Channeling is where you get like a path is where the air is passing through rather than mixing with entire garbage. So we have to avoid those. Fast turning after 3 days, then you can do after 5 days. Again, it depends on what kind of digester, what kind of reactor you have. I'll show you some examples reactor like in next couple of minutes. So oxygen requirement can be calculated using this formula, where again this formula is for the formula of the waste of the BVS component, that biological volatile solids, because that's what will react. So 1 mole of this will react these many moles of oxygen to produce these many moles of this stuff. So in process where forced aeration, total air requirement, airflow is essential. So if you're putting pumps in place, if you're putting like forced aeration in place, so you need to, if you're passing air through, so you need to calculate oxygen requirement very carefully so that you can come up with those pumps requirement. Windrow composting, we can do it by mixing and turning. So whenever we mix and turn, so that gives our windrow compost. Order become a problem when section of compost becomes anaerobic, and then because it's the anaerobic gases which gives us order. If it's an aerobic system, if it's 100% aerobic, you should not see any smell. It is the reduced gases like sulfur sulfide and those reduced sulfur gases which gives us the smell. This is some example of at what temperature these pathogenic organisms die. You don't have to remember any of these names, or if you just look at maximum temperature given there is 62, 63 degrees centigrade. So if you can just bring it around 65 for some time, for an hour or so, or even 3 minutes, it says 3 minutes at 62, 63, that particular organism will die, and otherwise most of the organisms is 60 and below. So if we can keep it 60 and below for some time, for a few hours, our pathogenic pathogens will be destroyed during the composting process. Now, how much time it takes for compost? It depends. If you have a mechanical system, you can do it in 7 days. If you have a highly mechanized system, if you have piles, windrows, which is turned, it is 9 to 21 days. If you have a static piles or some mixing, 30 to 40 days. There is no composter in the world which can do compost in 24 days. You may have seen several advertisements in India and some other places too, where they claim that they are doing a compost in 24 hours. We all are a student of civil and environmental engineering. We have done our civil environmental engineering, so we know that it is not possible. It is it's actually like microbes to do something within 24 hours. It is actually not possible from a microbial point of view, based on whatever wastewater microbiology we have studied, or microbiology that we have studied. So if you get that kind of claim, please ask them tough questions, and then you will find out that it's just a marketing gimmick. There is no composting happening in 24 hours. So it takes time. It will, if you have a highly mechanized system, that also it takes a week. So it cannot happen before that. You can make something, but that will not be compost. You can make it totally dry and do something of it, but that's not really compost. So when is the process finished? When upon turning the compost, you do not see change in temperature, because the change in temperature is telling you what is the it basically change in temperature is giving you whether the microbial activity is happening or not happening. So if there is no change in temperature, that means no microbial activity has stopped. So if the microbial activity is stopped, means there is no much organic matter left. So your compost is ready. So organic fuel is gone. Or material left will smell like earthy smell, like humus, like dark brown and as earth smell. Remaining compost is typically half of the original volume. Then you put it in curing for additional 2 to 8 weeks. That helps to grow the microorganisms there, which helps in producing good quality compost. So compost, you can put it in dry conditions and you turn it occasionally. You have a more diverse microbial population, provide a stable source of nitrogen, and CN ratio will be less than 25:1. You can reduce and you can also with when it gets cooled down, so seeds can also survive. We do germination test to do that, find out that quality as well. Aerobic composting, you can do agitated or static. Both agitated means where the material is agitated periodically to introduce air. Static means material remains static, air is blown through the compost. So whatever it gets, it gets. So windrow composting, typical, all of us are familiar. And you can put it in windrows, you turn it regularly, you can use front-end loader. Complete composting can be done in 1 to 3 weeks, then cure for another 3 to 4 weeks yeah, to make a good quality. Aerated is static pile where you inject air. Compost is on the top of a blower, so you have a blower system. You are injecting air through it. Blower is controlled by a timer based on temperature. So either a positive or negative pressure. When the temperature goes down, that means the aerobic, that means the microbial activity has gone down. You pump some air. You pump air, you see the temperature going back up, and then you stop. And again, temperature goes down, you pump some air. So you can put some sensors, and it can go on automatically. So you can blow air or you can suck air. You can do either pressure, positive pressure, or a negative pressure. Both is done. And it takes 3 to 5 weeks. And the compost is cured for another 4 weeks, and then your compost is ready. So this is a turner which will go and do the turning part. You will have things like it will go and mix it as you make progress in composting. Then this is a like a reactor kind of compost where you have this is your horizontal reactor. So you have the waste which is covered, and this is the pipe here which is blowing air through it. You can have a mechanical in-vessel system where you put the waste, then it goes from one tray to another tray to another tray and kind of goes down. And by the time it comes down, it is got composted. It takes 4 to 7 days. It's a rapid process. Now, you can make this kind of composting, but it's costly. So essentially, you pay for the speed. So depends on what is expense. If you don't have the land availability and you have to make a compost, you can go for this something like this. But if you have the land availability, you don't have to go something like this. Why to spend more money if the land is not a problem? If the land is a problem in big cities, it probably, yes, you can go for something like that. Again, you look at water content, oxygen, it has a better control, temperature, order. Then since the composting process was fast, you need a longer curing time. So now the curing bed, you require more curing bed. So land-wise also, you're not really saving much, but you can take it to outskirts and let it happen the curing over there. So it's more expensive due to mechanical configuration. You are paying for the speed. So this is this from this place to this place. So waste is loaded on one side from this and then it rotates. This keeps on rotating. So this keeps on rotating, and it takes from this place to this place to come. It takes almost 4 days, and in 4 days when it comes out, it's this kind of material. So again, it's not compost yet, but it's degraded now. It can be taken to the curing bed where it will be kept there for a longer period of time. You can have these kind of agitated bin system. You have these bins which for composting, where you have this mixing device. So this device kind of gets in to those piles and keeps on mixing. You see all those hands in here, all those kind of hands or teeth, whatever you want to call it. So this goes into the waste and keeps on mixing the garbage. So this actually comes here. You are saying a small. It has a long arm. It can extend. So it will go into the garbage and keeps on mixing them. So, and these are the blower system where you are adding air through the to those compost piles over there. And whatever this building inside is the compost plant. So even in a good compost plant, you will have some anaerobic activity happening. So you will have some smell issue. So and then if you have a nearby residences, that smell may become a problem. So what some facility does is they have this building under vacuum. So they suck all the air, all the dirty air, pass it through a biofilter, which I think I don't have that picture. Okay, they pass it through a biofilter, and then the clean air is released to the atmosphere. You can do backyard composting too. You can do it if you have a bigger house. You can do the backyard composting, which can be used as well. So when you do I think you have already done a compost plant design. Some professor talked to you about that. But just very quickly, you should have enough space to handle 2 days waste at least. So in case of vehicle, handle collection vehicle, surge amount, downtime of the plant should be processed as a uniform rate. Inorganic materials should be separated. You should how specific, like how much flexibility allowed, just MSW from local areas, or you are using some other waste stream as well. Can the other organic waste needs to be added, like sludge, agricultural waste and all that? Is the end product free from pathogens? QC control. You have to do the fly and odor control, HVAC control as well, and where to store, handle finished compost, where the market, are there zoning bylaws in terms of waste collection and all that? So those is needed. So specifically in terms of design parameter, you have process design, carbon nitrogen ratio, moisture content, composting area sizing, and finished compost storage area, runoff collection, if you have to do a runoff collection, land treatment design for runoff, like like, because whenever the compost is there, you will have some moisture, and that moisture is kind of essentially a leachate, and with the rain and all, you will have some stormwater runoff as well. So you need to have some sort of collection system and treatment system for that. And costing, like how much cost it will be, whether you should go for highly mechanized or whether you should go for manual, depending on the cost. So organic residue, if it's source segregated, it could be composted, digested, and you can take it to the market for different application. In terms of quality, there are heavy metals and all. I think tomorrow morning also you have a lecture on some of these quality issue. So that's why I kept my lecture more on a big picture, like what needs to happen to keep the compost quality good. But nitty-gritty detail, you will again, I think tomorrow morning somebody is talking about, as per the program, if I remember, you have something on compost quality too. So there are heavy metals, considered like heavy metal. This is a compost quality standards from Canada. We have Indian standards too. This is a good quality compost and category B compost, and there are limits in terms of how much heavy metals you can have. And these are all based on dry weight. With all these soil standard, compost standards, they are always based on dry weight. Can anybody tell me why? All these standards are based on dry weight. Because different compost may have different moisture content, isn't it? So different, if you keep the wet weight, the numbers will be different. So if it's dry weight, means no moisture. So we can compare with those, we can have this standard. Otherwise, if it's a wet weight, my compost may have 10% moisture, your compost may have 20% moisture. But then we may have the same arsenic, actual arsenic mass, but one compost will pass and one compost will fail in that case. So that should not happen. So these are some of the standards, and based on, because they are certain toxic properties of these, that's the reason why they are not supposed to exceed these numbers. Then there are standards for pathogens. Again, you have this slide. If you want to look at those numbers, you can look at it later. But there is a standard for pathogens. There is a standards for SAR foreign matter. SAR foreign matter means nails and glass and all that. And then what should be your maturity and stability in terms of respiration rate of the compost. Temperature rise should not be more than 8 degrees centigrade above the ambient temperature. That means organic matter has degraded. CO2 evaluation rate should be less than this. So those are just to make sure that we have good quality compost coming out. Then we have compost quality standards from India. If you compare with the Canada one, the numbers are slightly different, more or less in the similar range, but the numbers are different. It's on milligram per kilogram, again based on dry basis, except pH value and CN ratio, which is on wet basis, but otherwise all are dry basis numbers. So then there is a comparison table for different countries. You can look at it for different heavy metals. What is the compost, depending on the type of compost as well, where there are different different countries, you have different concentrations out there, which you can have a look at it. And they are all based on certain risk assessment protocol. Okay, So I think we can skip that part very quickly. Now we have only a few minutes left. Very quickly, I'll show you some two composting like plant. This is a compost plant. Again, both of them are from Ontario, where I was working earlier. In fact, I was involved in both of these plants as a consultant. So that's why I have these pictures from them and some of those information from them. So I'm just sharing it with you. So they had a central composting facility for city of Hamilton. It's a source segregated organics. So food waste was collected separately. This was the company which was running it on behalf of city of Hamilton. So the plant was made by city of Hamilton. So see, one thing I want to tell you that although we think that North America is a capitalist place, there we expect there to be everything privatized, isn't it? But I see that in India, we think that waste management should be privatized to that extent. In most of Western countries, waste management actually is still, like majority of the waste management task is still done by the city and the state government, not by the private agencies. Because in an area like waste management, it takes long time to recover the return of investment. ROI is pretty long. So we do need our cities and state to be strengthened in terms of managing the waste. We have these issues of corruptions and all those things. Let's somehow solve those, because private parties, unless they are ready to be there for a long period of time, otherwise it's a marathon. Waste management is a marathon. It's not a 100-meter, 200-meter race. It's a marathon race, which they have to be there for a long period of time to really make an impact and really make money. Otherwise, they will just be after those JNURM or Swachh Bharat Mission, whatever that program gives them some subsidy, they will get that subsidy money and they will disappear. And that's what happened in last 20 years in India in waste management sector. So this was actually built and by the city, but operated by a private company. Maple Reindeer is a private company which is operating. But they had a city project manager who was, the city was involved in this. So it's an aerobic in-vessel composting, 60,000 metric ton processing capacity per month. Processed this is per year. Processed 32,000 metric tons in 2013. It serves around 1.3 million residents of the city. Processes all source segregated organics and leaves and other yard waste. So they have two tunnel phase, a curing phase. Nope, they don't have no plastic. So they are it's just getting only food waste and these leaves and other stuff. So there are issues of even in their non-sorted, they do get plastics in there. They sometimes household hazardous waste is hidden. Odor, smell is a problem. Then they had the new guideline, which was also a bit of concern for them. It's there. Sometimes they are also getting non-native plants. They're also getting some animals, their microorganisms. So there are a lot of other issues which is coming into their area as well. So that's a picture from there, the truck coming in, dropping those organics. Then this is the central composting facility, and they have these tunnels where the composting is taking place. The white pieces that you see here is not plastic. They're actually tissue paper. They are the tissue paper from the toilets and others. So that's those are your white things that you're seeing over there. Then they have a maturation place as well. Then other example very quickly that another 30,000 tons per year capacity of source segregated organics at city of Guelph, where I used to live actually. I used to live in this city, and I was part of the solid waste management committee of that city. I was one of the member. So they would have a technical member there, and I was member for almost 4 years on that, and we did city design of several facilities there as part of the city team. So here again, Maple Reindeer, this plant was designed by Maple Reindeer. They partnered with AIM Environment who operates that plant. So 30,000 tons per year capacity. It was designed, built, operate, and contract. There was a 5-year contract, and then they had also further extension. So these are the capital cost. It gets 10,000 tons from city and then 20,000 tons from other areas nearby. So there's only 8 members which run this facility. It's an equipment intensive, not people intensive operation. So you can see the plan view. So this is, they have this maturation area. This is the tipping area where the waste comes in. This is the transfer area. That's the compost bunker. From compost bunkers, they take it to the maturation area where it's matured. And then from the compost bunker, any smell goes through this biofilter, and then it goes, it goes into a, they have those, like a chimney where through the air, like air is exhausted. All these is under a vacuum. These are all under a vacuum controlled, so that they have houses nearby. So they have to make sure that there is no smell. So this is some example where the waste is coming in, then it is getting into mixing and shredding. Then it goes to this phase 1 composting, then it goes to phase 2. So we have 4 bunkers here, 3 bunkers there. Then it does the screening, then it goes for maturation, then again the screening, then finished compost goes to the market. And this entire building envelope is in vacuum. So air from here, the dirty air from here goes through this biofilter, and which is clean, and then this is a stack from where it is released into the atmosphere. So again, I'll just skip this. If you, for the screening and maturing, you all know all that. And then they have this odor control using this biorem biofilter. We have worked on this biofilter, and we also did a life cycle LCA on that biofilter when we were there. Then they have to follow this regulatory framework. They have a SCADA system. They can see everything on a mobile phone as well. So they have some changes. Although those nicely run plant also has some certain challenges in terms of ammonia sensors, wind stiver, wastewater tank, airflow, humidification chamber. Then there are new composting regulation. Those they have order management. Those challenges are also there. So major concern, you have quality standards for heavy metals, impurities. It's vary between countries and region. They are mostly dependent on specific situation. Soil structure, background concentration of pollutants, agricultural practice, they also dictate what should be the quality. Compost quality is best in countries with separate collection of municipal bio-waste. If you don't have separate collection of municipal bio-waste, the quality does suffer. Plastic pollution is going to create more problem for composting. And I have recently been that we have to have a better quality assurance system. In Flanders and Germany, are these standards expressed not only in weight but also in surface area. Okay, other concern, we have overemphasis on mechanized process, lack of vision, marketing plan. So these are, again, from an Indian point of view, we are talking about that, how to make compost marketable, finding a use for the finished compost, poor feedstock, neglecting the economics of composting, securing finances for those companies, and looking at the because the revenue generated from sale of compost is actually pretty low. That does not cover the processing, transportation, and application cost. Subsidies can only be there for some time. Subsidy cannot run the program in a long run. Municipal authorities have to do the adequate waste collection, source segregated waste collection. Pathogens and weed, those order issues, rat issues, poor integration with agricultural community. We make compost, but our agricultural communities is still buying chemical fertilizer. So incentives such as fertilizer subsidy, that's again, so we have to put some in. There are some incentive already in India. Land requirements, it is not that much, but it can again be some constraint. So you have to look at the cost benefit analysis of a composting process. Let's just skip all that. Okay, these are fine. So there is some research going on in addition of biochar for composting as well, which is biochar use on, it can help in antibiotic resistance quality, especially during manure composting. There are some issue is there in terms of discharge of antibiotic resistant microbes because of application of compost, and it says that biochar can solve. In fact, there was recently a PhD was done in NIRI, Nagpur, on the addition of biochar as a solution for composting. So I was involved as an examiner for that. So those are, so there are some recommendation in terms of capacity. We talked about that, technical and managerial improved policy, do the capacity building, increase public education, do the full cost accounting, integration with agricultural and horticultural activity, more focus on implementation and day-to-day operation. So those things are needed to make a compost really successful. Provide technical assistance, low-cost facilities, evaluate loan, land for composting, public awareness, using use compost in public works and agricultural in our own departments, with reducing subsidy on chemical fertilizer and all that. So all these are kind of recommended in do's and don'ts. Several do's and don'ts are listed here. So I think that's it. I hope it was useful. If you have any question, we have taken, I think I was supposed to end at 4:30. It's already 4:38. But still, if you have some question, we'll be happy to take it, unless Professor Chandrasekhar has some other, I don't know whether you have another lecture after this. So if you have any question, feel free to ask.
Sir, excellent talk, sir. A lot of learning and great case studies. Only the implementation. At least 1, 2. That is the thing.
Yeah. So you are mostly from which? You guys are mostly from Andhra Pradesh and Telangana, or from all over India?
We are from all over India.
All over India. Okay. Okay, good.
Hello, sir. Sir, is it possible to tell the quality of a compost by just physically examining it? I do understand that. I mean, there are a lot of parameters, but those needs to be tested chemically, right? For all the parameters that you spoke of, that is in terms of the minerals.
Yeah.
So, is it possible to physically examine any compost and say whether it's average or good or a bad compost?
I would say no. My answer, but on a like with experience, with somebody who is working with compost plants for say 10-15 years, he or she can look at a compost and smell the compost and tell you whether it's a good compost and what kind of issues. But that will be based on the maturation of the organic material.
Okay.
But whether there is a heavy metals present, whether there is a heavy metal present, or whether there are other contaminant present, that you cannot say by just seeing it. That you cannot do just by seeing it. So you have to analyze it first. But yes, there are people. There are people who can tell you based on looking at compost, especially taking compost in their hand and smelling it, and tell you that yes, this seems to be a good compost. That's only like it seems to be a good compost. That's what they can say, but not more, not nothing more than that.
Thank you.
Any other question? So if you don't have any other question, then I think that's it. Thank you. I hope it was useful. The slides are with Professor Chandrasekhar. I think he will share it with you guys. So, okay, if you are interested to share the slide. And someone was asking for my number on here. Dr. Madhuri.
Yes, sir.
I can give you my number. That's not a problem. It's actually available on, if you go on my website on IIT Kharagpur and open my CV, which is there, it has the number. I just put it on the chat box. You can see that.
Okay, sir. Thank you so much.
That number has WhatsApp. That number
Okay,
has
okay,
WhatsApp
sir.
too. So
Yes, yes.
Okay. Okay, thank you. Then I'll see you someday, somewhere. We'll meet again.
Yeah, thank you so much.
Thank you. Bye-bye.
That's it for the day. Let's meet tomorrow morning 8:30 a.m. for the next session.
So at what time would be assessment?
Assessment will be mostly before lunch session, I think.
Okay, and in the afternoon session?
I think this program will be wrapped up before lunch itself.
Oh, is it? Okay, yeah. Thank you, sir.
Most probably. I'll confirm you in the groups.
Okay, yeah. Thank you.
Thank you, sir.
Thank you. Thank you.